Hello everyone and welcome back to another SLHL IB chemistry video. Today we're going to be looking at reactivity 1.3.5 and more specifically at fuel cells. So how do fuel cells work? Well, a common kind of fuel cell is the hydrogen fuel cell. And this utilizes the reaction between oxygen and hydrogen to create water. Obviously, this is not a balanced equation. Now, what this does is that instead of the chemicals undergoing combustion, the fuel cell converts chemical energy into electrical energy rather than first emitting it as heat. So this means that as the reaction occurs, more reactants need to be added in to keep it going at a consistent pace. So let's draw an image or a diagram of what a fuel cell would look like. So here we have a diagram of what a hydrogen fuel cell would look like, and as we see, hydrogen and oxygen both enter in here through the sides and they will reach these electrolytes. At the negative terminal we have hydroxide ions, whereas in the positive we will have water, and at the very middle we will have a NaOH or sodium hydroxide electrolyte solution, aqueous sodium hydroxide, and it's contained within the cell using these porous electrodes to allow the passage of water, hydrogen, and oxygen through them. And I believe that we will have to know the half equations. We will not have to know the half equations. And these hydrogen fuel cells can also be made using phosphoric acid as the electrolyte. And that would also give out an overall equation of 2H2 plus O2, giving you 2H2O, gas, and liquid. Cannot forget your state symbols are the half equations that occur at each anode, or at each electrode. So at the anode, which in this case will be our negative terminal here, we get oxidation, which means a loss of electrons, so we get this to form 2H2O plus 2E minus, and at our cathode we will have reduction because this is a redox reaction. And we see how this can almost fuel itself back if we were to continuously apply hydrogen and oxygen, or continuously supply hydrogen and oxygen back into our fuel cell. For our phosphoric acid electrolyte, we will have still oxidation at the anode, but instead of 2OH, we will get the formation of 2 hydrogen ions with 2 electrons, and our reduction at the cathode would look more like this. Not exactly the same, but not all too different either. Our methanol fuel cells, using a alcohol, we have CH3OH, that's your methanol, plus water to give you carbon dioxide, as we discussed earlier, plus 2 hydrogen, 6 hydrogen ions, and 6 electrons to balance out this equation, we get a funky looking thing over there. You can do this when it comes to, say, simplifying or maybe creating empirical formula, but if you are asked to state the actual formula of a reaction, do not balance using decimals. Back to what we're saying, all of this will give you 3 water molecules. Obviously, we must be environmentally conscious because of this carbon dioxide over here, which pollutes. There are other fuels apart from hydrogen that can be used, such as a methanol fuel cell, but this will produce carbon dioxide because methanol, methane, alcohol, therefore carbon compounds, which we know serves as a pollutant. An advantage of this kind of fuel cell over here is that hydrogen fuel cells do not pollute, as the only product that they have is water. But one downside is that we have to frequently replace the reactants, such as hydrogen and oxygen, as we mentioned earlier, and this can also tend to be quite expensive, not only the technology, but the replenishment of these reactants. One advantage, though, is that they do not need an external source of electricity to recharge, and they only require these elements within them.